I will be explaining how the RAM works. So let's take a scenario for an example. Let's say there is a Microsoft Word file called assignment 1, which already stored in the computer. So now when we double click the file, which is the assignment 1, so what happens is that the operating system will locate the file from the secondary memory, and then it copies the information into the RAM. It only copies the information that is needed at the moment, rather than it copies the entire information to the RAM at once. Then the next step, what happens is, when we, let's say, when we edit the file, like adding image or typing some text, let's say we type a letter A, we can view the changes made on the screen. So basically the update is taken place in the RAM only, and not yet to the secondary memory. So when we click the save button, then only it will store the changes permanently from main memory to the secondary memory. So after that, when we, let's say we close the Microsoft Word program, once we're done with our task, what happens is that the RAM will deallocate the space. Basically it free up the space for other processes.
Good day everyone, I'll be presenting on my part, which is computer memory formation. So computer memory formation involves taking in various types of information, like what users type or sensors detect. This data is then changed into a computer friendly form through encoding, converting it into a series of zeros and ones. The computer stores this transformed data in two main memory types, which is temporary use RAM and long-term storage, which is HDD and SSD. Each piece of data is given a unique address for easy access. The computer's brain, which is the CPU, retrieves and processes data from RAM, which is quickly, but loses data when the computer is turned off. Long-term storage keeps data even when the computer is turned off. Retrieving data involves using these addresses with RAM, quickly providing frequently used data, and secondary storage for less common data. After retrieval, the data can be shown to users through devices like monitors or printers. This whole process covers the life cycle of data in a computer, from input to storage, processing, retrieval, and finally showing the information. That's all from me.
Hi Madam Magalia and to my fellow friends. Today I'm going to talk about internal memory and external memory. Internal memory is a data store inside this storage that can be accessible easily by the CPU and also while running in the laptop. It's a part of the main component of a computer system. The types are register, cache memory, and main memory. Usage of popularity is modern computers primarily used for semiconductor memory, especially in internal storage. Desktops are using in DDR4, DDR5 and LPDDR memory. The development of internal memory in 1940s are using in vacuum tube era. In late 1950s to 1970s are using core memory with magnetized rings become widely adopted. In 1960s are using semiconductor evolution with secure image transforming memory technology. In 1980s till now, they are using SRAM and flash. SRAM is faster used in cache, while flash is non-volatile in USB and SSDs. DDR with RAM, 1990s till now, from DDR, DDR2, DDR3, DDR4 with the system clock. 3D X-Point innovation from 2015 till now are using Intel and Micron development is higher performance than traditional, which is NAND. Next, I'm going to talk about external memory. A data instruction stored inside this storage cannot be accessible easily by CPU and not integral part of main component of a computer system. Example are magnetic disk, optical disk, and etc. Usage of popularity used for backup, data transferring, and expanding device storage also. Essential for professionals, students, and also new users also. Development of external memory from 1950s in 19 to 1960s used paper punch cards and magnetic tape. 1970s to 2000 are using floppy disks used for data storage, software distribution, and also backups. 1980s to 1990s they are using CDs and DVDs for using in storing the songs and music and also data backups. Late 1990s till now they are using USB flash drives, which is also they are using type C also they are for fast boosting. And also 2010 till now they are using cloud storage based on the solution from cloud. SSD from 2010 to now fast data transfer, and durability for backups and storage. From 2000 to now, network attached storage, which is NAS, shared storage over networks used in homes and businesses.
Hello everyone, my name is Kavinesh. Today I will be explaining about critical components of computer memory, which is internal and external. Starting with internal memory, it's like the brain immediate storage integrated into the motherboard through chips. These chips, equipped with millions of transistors, store data as binary code 0 and 1. The CPU communicates with this internal memory through a memory controller facilitating real-time multitasking. External memory, on the other hand, encompasses separate storage devices like HDD, SSD, and more. Mediated by storage controller, data transfer between the CPU and external memory has revolutionized the way we store and share information. In essence, these two components work together, forming a robust memory system crucial for a computer functionality. Thank you.
Hi everyone, my name is Roshan. So today I'll be presenting on memory description on capacity and performance. Firstly, we have internal memory. Internal memory has smaller capacity and faster speed compared to external memory. And external memory has larger capacity and slower speed. For example, RAM has a series of 4 GB, 8 GB, and 16 GB. But for external memory, external SSD has a example of 120 GB, 240 GB, and can go up to 2 terabytes. Next, memory density. Memory density in internal memory is high. It is used to store larger data in compact type. Whereas in external memory, the density is low. Next, moving on to performances. For the performances, internal memory's latency is very low. It has almost instant data access, especially for RAM and registers. Whereas for external memory, it is higher and it's based on the technology implemented. So read and write time is higher in external memory. Next, for throughput for internal memory is higher, whereas for external memory it's lower. And the granularity is better in internal memory, whereas granularity in external memory is less and may affect access. For the reliability, internal memory has higher reliability, where data is not lost so easily. Next, minimal data corruption. Chances of losing data is very less in internal memory. Whereas for external memory, it is less reliable, especially for optical drive and magnetic disk. Exposure to data corruption and disk failure is very prominent, but it can be overcome now by using SSD, since SSD has overall better performance compared to HDD. And also reliability for external memory in SSD field is higher compared to other external memories. So SSD are the most current technology. Thank you.
Computer memory formation process illustration. First, we have the input is gonna pass to the CPU, the central process unit. Gonna forward for first to ALU to execute the simple calculation like times, plus, minus, and so on. Second is gonna pass or forward to the CU, the control unit, terrestrial operation. Uh, Illustration to the memory ALU and input and output devices on computer for how they will respond the instruction. Of course, the control unit consists to encoding. The encoding is the process of transform meaning of information into a suitable from for storage. Then it's gonna forward to register. The register is used to quick accept, transfer, and store the data, and instructions are used to the CPU immediately. This is the final of how the input processing in the CPU. Then it's gonna forward or pass to the memory unit. It's gonna explain by Rabi.
Okay, so if in case of the register cannot able to store the data anymore, it can forward it to the memory unit. The memory unit consists of two hardware such as short-term memory and long-term memory. Short-term memory has like SRAM, and then DRAM. It's used for immediate tasks or quick access to the data. And then for the long-term memory, it consists of two memory, the local secondary memory and remote secondary storage. And the both of us, short-term memory and long-term memory, will be consolidation and retrieval the data each other. Once once the data has been stored, it will gonna bring back to the CPU, and after the CPU, it's gonna be the output line.
Good morning. My name is Muhammad Rijaman. I'll be explaining about storage lifespan. For internal memory, it has relatively short lifespan and expected to last for a few years. However, the lifespan depends on the type of memory and how it is used. For example, memory that is constantly being written to will wear out faster than memory that is less frequently used. For external memory, it has a longer lifespan than internal memory. For example, hard disk drive HDD can last for 5 to 7 years, while SSD can only for 10 to 15 years. And so for my next part, I'll be explaining about the durability. So for the internal memory, internal memory is very durable and not susceptible to physical damage. However, it's important to protect it from ESD, electrical discharge. For external memory, it is more durable than internal memory. They are physically more robust, can withstand drops, and is more is more durable than SSD internal. So in summary, internal memory has a short lifespan and sensitive to ESD and weighting, and the capacity is limited, but the speed is very fast. But for the external memory, it has a long lifespan and more durable, and the capacity is larger, but the access is slower than internal memory. So that's all for my part.
In conclusion, the computer memory formation process involves several different steps, all the way from data input to data retrieval. Address formation is extremely significant in efficient data organization and accessibility. Internal and external memory have different characteristics, mechanisms, and purposes, with internal memory focusing on active data processing and external memory focusing on long-term data storage. There are differences in volatility, accessibility, and addressability also serve to make them suitable for their specific different tasks. The capacity, performance, as well as reliability also differs between the two types of memory. External memory offers a longer storage lifespan relative to internal memory. The durability difference, however, between the two internal and external memory differs according to the storage media, with some having more durable internal memory and others having more durable external memory, but generally in favor of external memory. Understanding these aspects is crucial for proper understanding of computer memory formation process.